This is AP Precalculus Notes Part 2 for Topic 2.13, Exponential and Logarithmic Inverses and Inequalities. So again, this is just adding on to stuff that we already know. If you have an exponential function, it's going to look like this. If you have a log function, it's going to look like this. We know that the h and h here are going to be a horizontal translation. We know k and k here are vertical translation, and we know a is going to be a dilation, a vertical dilation. Anything that we need to know? Okay, so these are the general rules. So one thing that I noticed that the answer key is doing differently than what I do, they switch x and y, and they don't change it to f inverse of x. They just call it y because it's easier to write over and over, and then they just write f of x at the very last step. I'm going to be doing that in this video as well. So let's go ahead and try to find the inverse of the following function. Again, the idea here is we're just switching x and y. So this, I'm really going to call this thing, this is y equals this entire function. And now I'm going to switch these two x and y variables, and I get this new equation, which I'm going to have over here on the left, which is x is equal to 3 times 2 to the power of not x plus 4, but y plus 4. I guess I'll leave the plus like that, and then all that minus 15. So in order to solve for y, I'm going to isolate this exponential expression, which means I need to get rid of this minus 15 and get rid of this 3. Which one do you do first? Well, it's reverse PEMDAS. So I'm going to get rid of the minus 15 by adding 15 to both sides. When I do that, I'm left with x plus 15 on the left, and on the right side, I'm left with 3 times 2 to the power of y plus 4. From here, I need to get rid of this 3 by dividing both sides by 3, and that will give me x plus 15 divided by 3, and then on the right side, I just have 2 to the power of y plus 4. And I would like to write this a little bit to the right because I know it's about to happen. I need to change this exponential form, and I guess I don't really need to do it this way. I'm going to do it the way that Bryan Passwater does it. I was about to write log of both sides and log of both sides because I'm so used to doing that. To save Rapunzel trapped in the tower, you have to do a logarithm. But the general way of doing this is you just rewrite it from exponential form into logarithmic form. So if I'm doing logarithmic form, this side now changes to, do a different color here, to log. The base is this base of the exponential function, so I'm going to say log base 2, and then these two quantities switch with one another, and you say that the power, or the logarithm up here is really this fraction of x plus 15 divided by 3, and this y plus 4 comes to the left-hand side, and we're going to say y plus 4. So we're almost done. We're trying to solve for y, so I have to get rid of this plus 4, and I'm just going to subtract 4 from both sides. And that's going to give me y is equal to log base 2 of that fraction x plus 15, all of that divided by 3, and then finally minus 4 because we subtracted 4 on both sides. That is the final answer with the extra thing that we have to do. Again, it says at the very end, we need to write the final inverse function using the correct notation. The correct notation isn't y equals. We're going to erase that, and I'm going to switch that out for an f. Was it an f or was it g? And then we have, it was originally f, so I'm going to switch that out for a g, let's keep an f inverse of x. That's f to the power of -1 of x. That's how we say f inverse. All right, nice. And then let's try another one. Example 2, find the inverse of this thing. So again, we're thinking that this is really y is equal to all of this, and we're going to switch the y and the x. So it's now going to say x equals, let's write this out, x is equal to, and then we're going to write out -3 log base 5, -3 log base 5 of, inside is x minus 4 and then plus 6. So y plus 4 and then minus 6. Did I write that right? Oh, y minus 4 plus 6. I had those backwards. My apologies. So it's going to go like this. Oh, y minus 4 plus 6. It's really silly to make a mistake this early in the process. Okay, it looks good. We switched our x and we switched our y. All we need to do now is solve for y. So I'm going to isolate the logarithmic expression, and I can switch the log expression into an exponential form. So I need to get rid of this -3 and get rid of this plus 6. The first thing I'm going to do is get rid of plus 6 because of reverse PEMDAS. I said that before, but let's just make sure in this video I explain it thoroughly. With PEMDAS, PEMDAS, if you remember, is please excuse my dear Aunt Sally, which stands for parentheses, exponent, multiplication, division, addition, subtraction. normally we go in this order when we're trying to simplify just numbers, but if I'm trying to undo numbers, if I'm trying to solve for x, I go this direction. So I'm trying to get rid of addition and subtraction first. I'm getting rid of this addition first and solving. It's just basic algebra. You learn about this in Algebra 1. I just want to make sure that I cover it very thoroughly when we're doing these equations. So the first thing I'm going to do is I'm going to subtract 6 here, subtract 6 here, which means my new equation is we've subtracted 6, so it's x minus 6, and on the right side I'm left with that negative 3 log base 5 of this y minus 4. Again, we subtracted 6, so you're gone. The next thing that we need to do to isolate this log expression is to get rid of negative 3 by dividing, because what was happening before is negative 3 is being multiplied. The inverse operation of multiply is to divide. So if I divide both sides, I have x minus 6, and now it's being divided by negative 3, and on the right side, the negative 3 is now gone because we've divided by the negative 3, leaving behind a log base 5 of y minus 4. All right, so from here, we've isolated the logarithm. It's now time to write this thing in exponential form. So this 5, that's the base of the logarithm, is now the base of the exponent. So I'm going to say, a new color, 5 to the power of, and then these two switch. So this is now the power. I'm going to say 5 to the power of x minus 6 all over 5. That's the power. Oh, I have to write 5. Negative 3, my bad. And then this y minus 4 is going to come to the left-hand side, which means this y minus 4 is going to come down over here. We're going to say y minus 4 is equal to that 5 to the power of x minus 6 all divided by negative 3. We're almost done. The only thing I need to get rid of is this minus 4. We're going to add 4 to both sides. So my final expression, I don't want to write y here because I know this is my last step. This function was g, right? Yeah, so it's going to be g inverse. I'm going to say g inverse of x is now equal to, I still have this 5 to the power of x minus 6 all divided by negative 3, and I added 4 to both sides, so I'm going to say plus 4. And there's my final answer for my inverse function. Did I box my last question? Here, let's see. I don't think I boxed it, so let me, it's a little bit out of the way, so let me grab those, and then I can box it. Make you into a rectangle, please. No, okay, it's not having it. Moving on to example 3. All right, so, this one is tricky. Okay, so look at how this question is being asked. We're saying, hey, we have a function, it's an exponential function, and it's this thing right here. Cool, it's exponential, and we say, hey, k is the inverse function, which means we know that k, the inverse function, is some sort of log, because that's the opposite of an exponential. Okay, and it's saying, what value of x makes k that inverse function, that's a log function, we want the output to be 1. And this is just knowing the definition of an inverse. An inverse function means you switch the x and the y's. So the definition here is we have our x's and we have our y's, and these switch with each other. That's the definition of an inverse, which means what used to be the input, I can't spell input, will switch to becoming the output. And similarly, the output will become the input. Again, that's kind of redundant to say, but watch this. This is the output. I'll be very explicit right here. This is the output of our function k, which means because I'm switching my output with my input, this is the same as saying, I'll do this maybe in a different color to draw this. This is actually the input of h. Those are the same thing. Output switches to input, and you switch from the inverse functions, right? So the input of h is 1. That's what it's really saying here. So we have a function h. It's right here. There's our function h, which means input 1 into h. So what it's really asking is, what is h of 1? That's all we had to do. You have to be able to interpret the problem, which is why I spent so long doing that. But it's just saying h of 1, which means I'm going to do 3 to the power of, there's the 1 that I'm being plugged in, right? Plus 1, all minus 2. I'm going to make this really color-coded friendly. So I'm plugging in 1 here and here for these x's. I just have to simplify this and I'm done. I can say, okay, this is equal to 3 to the power of 2 minus 2, which is equal to 9 minus 2, which is equal to 7. And that's the final answer. And interpreting the final answer, I mean, you can check it too to make sure it's okay. But saying, hey, if I plug in 7 into k, which I don't know what k is, it's some sort of log expression. But if I were to plug in 7, I would get out 1 because the opposite is true over here. If I plug in 1 here, I get this to be a 7. All right. So a little bit confusing for example 3. I hope I explained it thoroughly enough. And we're on to the second of 2 pages. There is no, worksheet A comes next. This page is ridiculously hard, especially you. All right, so let's jump in. we're essentially doing the same thing where we're setting this thing equal to 0, but now we're trying to figure out where these y values are greater than 0. So I need to set this thing equal to 0, where I find my boundary points. Where do I switch signs between a positive and negative? And then I'll finally answer my question. Okay, it's only positive here. But again, the first thing I want to do to find where it's greater than 0 is to find where it is equal to 0, to find those places where we switch between positive and negative or vice versa. So I want to set this entire function equal to 0. So my first step is to say, okay, that's now 0 is equal to, do I have to rewrite all of that? I will, just because you should as well. It's log of x squared minus 4x plus 7 minus log of x plus 3. Okay, that is the first step. We're trying to find where these boundary points are. And now that I have two logarithms, you might be thinking, these are properties of logarithms because I have a minus sign, which means we divide the inside. You're right, but that's too hard. Here's something easier. Add this thing to itself and then just move it over to this side. I'm essentially moving this log of x plus 3 over here and making it a positive, right? So I'm saying, let's say log of, what was the inside? It's x plus 3. Log of x plus 3 is equal to, end parentheses, I can speak, log of x squared minus 4x plus 7. Okay, now this has become one of those problems where we have a logarithm equal to a logarithm. Hey, if the outsides, technically it's a 10 down there, if the outsides are the same, then the insides must also be the same. And I can say, okay, therefore the inside, x plus 3, must be the same as the inside, x squared minus 4x plus 7. And at this point, I need to pause because I'm realizing once we have two different logarithms, there's a log here and a log here with variables inside of them, we might have a problem with our domain. So let me go ahead and move this down and talk about domain really quickly. But this is the next step in problem solving. I like doing the domain as fast as possible so I don't forget about it. So how do I do the domain? Well, the inside, x plus 3, has to be greater than 0. And the inside, x squared minus 4x plus 7, has to be greater than 0. That's the definition of where these things are positive. This one is easy. Its x is greater than negative 3. This one is a little bit tricky. I need to say that this is greater than 0. And how are we going to make this thing greater than 0? Well, I'm trying to think of factors. Multiples of 7 are 1 and 7. Oh. How do I make sure that this thing is always greater than 0? I'm thinking, do you have to do something disgusting? I'm actually using the answer key right now to help me out. How come the answer key doesn't look at where this is example 4, right? Yeah, in example 4, they don't even analyze it? That's strange. You need to analyze it. I'm going to do my own analysis. I don't see anywhere in the answer key. To make this thing greater than 0, you have to do the quadratic formula. There's no nice way. That's why I was hesitant to be like, do we really do the quadratic formula? Because if you do a ninja star, this won't work. What two things add to negative 4 and multiply to 7? Well, multiples of 7 are 1 and 7. There's nothing else to multiply to 7, and 1 and 7 will never get negative 4, which means you have to do quadratic formula here. And I can kind of see where quadratic formula is going to lead us. It's important to actually do this. So again, it's weird that I have to spend so much time doing this. Let me come and do this problem over here. What I have is, let me rewrite, x squared minus 4x plus 7. X squared minus 4x plus 7. Technically, that has to be greater than 0. I'm going to apply quadratic formula, and I'm going to say, let's sing the song, right? X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Remember, our values of a, b, and c are going to be, a is going to be equal to 1 because of this value right here, b is going to be equal to negative 4 because of this value right here, and c is going to be equal to 7 because of this value right here. So I'm going to say x, let's just do all this in blue. X is equal to negative, okay, b is negative 4, so it's a double negative 4 plus or minus square root. Okay, b squared is going to be negative 4 quantity squared minus 4a is 1 and c is 7. And this is all going to be over 2 times a, which is 2 times 1. All right, and simplifying this, we have positive 4 plus or minus square root. All right, we got 16. Okay, so this is going to multiply. It's still negative because I only have one negative. The rest of these are positive. 4 times 7 is 28, so it's going to be minus 28 all over 2. And at this point, I can be done. And it's one of those things that I could have just checked the inside of the square root here. Watch what's going to happen. If I have 16 minus 28, I'm going to get the square root of a negative. And whenever I have the square root of a negative, the only thing that's going to pop out of that is an imaginary number, meaning that this has no solution, because in this domain, we're restricted to all real numbers. This will never worry us. We'll never make this thing 0. If this thing is basically always positive for our numbers, then we never have to, it can't be 0. I don't have to worry about it. This thing over here is the only thing that we have to worry about, this domain restriction. So we're going to say that the domain restriction that we have to worry about is x has to be greater than negative 3. Let's go ahead and circle that so we remember that and continue on our problem over here. The first thing that we want to do is we want to get all of the numbers on one side, so one of these sides can be 0. Let's choose the x squared side. So if I subtract x, I'm going to get a negative 5x over here. That's going to be x squared minus 5x. And then I'm also going to subtract 3. Subtract 3, that's going to be a 4. So plus 4. All right. Left side we have 0. And then let's see. Oh, this one comes out nicely because if I do a ninja star, do I have enough room? Definitely have enough room. So if I ninja star this thing, what multiplies to 4 and adds to negative 5? 4 and 1, they're both negative. Multiply to a positive 4 and add to a negative 5, which means this factors to an x minus 4 and x minus 1. X minus 4 and x minus 1 is equal to 0. And then from here, we have, this is going to be, we just set this thing and we say x minus 4 can be equal to 0, and x minus 1 can be equal to 0. And then from there I can add 4, and I can say x is equal to 4, add 1, x is equal to 1. All right, are both of these things in the domain? So as long as we are greater than negative 3, if I'm thinking about it right now, I'm trying to figure out, do we have to worry about these? I said we didn't, but I need to really think about it. And yeah, I'm confident in that solution because, imaginary components mean that there's no solutions to that. That's the only domain restriction. Okay, so I'm very confident these have to both be the answers because both of these are in the domain. We are greater than negative 3. Let me go ahead and box both of those. We have x is equal to 4 for one solution, and we have x is equal to 1 for the second solution. And let's read the question, make sure we answered it. What are all the values of x for which f of x is greater than 0? Oh, dang it. So we're only halfway done. These values are important, so maybe I'll circle them. I shouldn't box them because we're not quite done yet. These are super important, so I'll circle them so I can find them for myself. What we need to do now is we need to set up a number line to figure out what happens at these junctures. Because if I have my number line, check this out. My number line has a 1 right here, and we have a 4 right here. We need to figure out what's going on. Am I going something like that? Am I doing something that goes like that? Am I doing something harder that goes like that? I have to somehow touch, this is the x-axis, and I'm either going to be a positive height or a negative height. So how do we figure that out? There's actually a lot of tools that you have to figure this out. I'm just going to do my favorite tool, which is, oh, and by the way, I should mark up if these are even or odd, but my favorite tool is just to plug in my favorite number 0 and to see if I am a positive or a negative. So first of all, check this out. With our equation over here, this is the one that I want to look at. Both of these are powers of 1, which means that these are both odd, therefore they are sign changers. So we can put a little circle saying it's a circle, it's a circle, it is a sign changer. We put an X if it's a non-sign changer. If it had some sort of even power like a 2 or a 4, then I would put an X through there, right? All right, so we know that they are sign changers, and let's go ahead and plug in a test value. Let's plug in 0 to see what happens. So if I plug in 0, into, I can just do this one, right? I have 0 minus 4, which is a negative, 0 minus 1, which is negative. A negative times a negative is a positive. Therefore, we have a positive value up here. So I'm going to say positive value up here. We have sign changer, which means negative, and sign changer again, meaning we have a positive. And then we have our final answer. We say, okay, we're trying to figure out for what values am I greater than 0. It's not equal to 0, just greater than 0. I'm greater than 0 here and greater than 0 here. So I'm going to say my answer is x has to be less than 1 or x has to be greater than 4. So those are the two answers. And this is just the fancy way of combining two different notations. I guess if you want to be lazy, you could just put like a comma in between. I like being fancy, so I'm going to do the union notation and say those two intervals are where we are positive. Excellent. And then let me check the answer key to make sure I got the answer right. I'm looking at the answer key. Weird. I don't see that as the answer. What's going on here? Oh, okay, I see my problem. What I'm saying here is this goes on and on forever and ever, which I thought it does, but check this out. I already told myself the answer right here. We have to be bigger than -3. I can't go to -5. I can't go to negative infinity. This is saying, yeah, go ahead and go to negative infinity. Anything that's less than 1 is fair game. And I already said, no, it has to be greater than -3. So what I need to say here, I need to have some sort of end boundary. Maybe I'll have a wall here. And I'll say, okay, at this point right here, is -3. I have a wall. This is like no man's land. This is not in the domain over here. I'm not allowed to go over there, so this bound needs to be restricted to say, hey, I need to be between -3 and 1. The way that you say that with inequality notation, you say, hey, x lives in between here, and you just put inequalities like that. And I believe you are allowed to be, oh, you can't be equal. Can I be equal to 3? This is a question. Up here, okay, this one is strictly greater than. I can't be equal to. So this one is also strictly less than because it's going the other way. Okay, so perfect. If you don't like that notation, you can say you have to be between -3 and 1, or you have to be greater than 4, which is from 4 to infinity. So these are the two different ways of doing that notation. Either way, that floats your boat, sinks your sub. Choose whichever one you want. All right. Example 5, here we go. What are all the values? Okay, it's one of those questions where we want one function less than the other function. That's kind of the same thing as saying this thing in a slightly different form. I'm just going to rewrite this exactly, but I'm going to plug in g of x is natural log of x. So this is going to be plugged in for g of x. This is going to be plugged in for h of x, and I'm rewriting this. Okay, ready, set, go. We have natural log of x squared plus x minus 5, which has to be, the sign here is a less than the other function, which is natural log of x plus 4, natural log of x plus 4. Okay, everything is set up. Let's go ahead and look at the domain restrictions right now. And we can say, okay, for the domain, and D for domain, the inside, x squared plus x minus 5, has to be greater than 0. The inside, x plus 4, has to be greater than 0. Where do these things happen? Well, the second one is easier. I can just say subtract 4, and I can say x has to be greater than -4. For this one, oh no, not again. Okay, well, a ninja star fails. I'll show that it fails so you can follow along. I'll try to do a ninja star. What two terms add up to 1 and multiply to a -5? And the answer is nothing. Unfortunately, the only factors of 5 are 1 and 5. 1 and 5, no matter how hard you try, are never going to turn into a 1 just by adding them together or subtracting them. So, yet again, we have to do quadratic formula. So it's kind of painful to do, but you have to check it. Otherwise, you can't get these totally correct. So if I'm checking quadratic formula, I think I'm just going to keep on working straight down here instead of moving off to the side. So quadratic formula, again, is x is equal to -b, oh, where's my plus or minus? Plus or minus square root b squared minus 4ac all over 2a. What are my values of a, b, and c? Well, I have a is equal to 1 because of this value right here. B is also equal to 1 because of this value right here. And C is equal to -5 because of this value right here. So 1, 1, -5. So if I'm plugging these in, we have x is equal to -1 plus or minus square root 1 squared minus 4 times 1 times, see zone, I have to remember, negative 5, all over 2 times 1, 2 times 1. Okay, so we have everything set up. Do I have enough room to do this? I'm just going to keep going down. I think I have enough room to just continue this down and hopefully get my answer by right there. Let's see. So from here, we're going to simplify. We have x is equal to negative 1 plus or minus. It's going to be square root of 1. Okay, watch this. Negative times a negative is a positive, so I'm going to have a plus here. And just by having this plus, I know that this is an actual number. Before, we had a negative in here in example number 4, which meant I can't do anything else. This is going to evaluate something which is going to kind of suck, to be honest. It's a really disgusting way to define a domain. But just continuing on, 4 times 5 is 20, so this is a positive 20. This is all over 2, which means when I simplify this, this is going to be x is equal to negative 1 plus or minus root 21 all over 2. And root 21 is just 7 and 3. 7 and 3 are not perfect squares, so I can't go any further. Again, this does turn into 2 different answers. One of the answers is negative 1 plus root 21 over 2, and the other answer is using the negative instead of the plus. We have negative 1 minus root 21. No, that's 12. 21 all over 2. Those are the 2 different possibilities that happen, and oh yeah, and because of this inequality, what's really happening here is we have to be greater than 0, which means this thing is on the outside boundary. So here, let me just explain this very quickly to make sure you see what I'm saying. What we have is a number line, right? And I'm saying, hey, here's the spot that you need to stay away from. It's toxic or whatever. It smells. It has smelly armpits, right? It's called 0. And I need to be far away from 0, greater than 0. If I'm less than some amount, then I have to be restricted. I have to be on the inside. This one, I want to stay away from 0. I need to be greater than 0. So there's some fence, some boundary perimeter, like a fence like right there. And you say, okay, that fence exists. And you can say, hey, I know what that distance of the fence is. That distance is 2 or something. And therefore, this distance is also 2. Stay away from 0. What we're saying is we know the distance now. The distance is that distance, and if I go the other direction, that distance. Those are the possible distances that I have to stay away from 0. They're not symmetric in this case, and that's okay. So my distance in this case is 1 plus root 21 all over 2, and 1, is it a negative 1? It is a negative 1, sorry about that. And a negative 1 minus root 21 over 2. Those are the distances away from 0. And everything over here, these are fair game. This one, that I do not want to be in there. That's essentially what I'm trying to say. Did I ever explain that? I might have. Okay, but these distances, I need to be greater than 0. So I need to say my x values for my domain. It's disgusting, but there it is. My domain values for that function, x has to be greater than negative 1 plus root 21 all over 2, or I guess technically at the same time, usually the word is or, because yeah, I have a range, or x has to be greater than, I guess it's less than because it's a negative though, huh? X has to be less than negative 1 minus root 21, why do I keep writing the wrong number? Root 21 all over 2. So those those are the boundaries. And that's, what is this? This thing is, it's basically close to 25, right? Root 25 is basically 5. So this number is a little bit less than 5. So if I do negative 1 plus a number a little bit less than 5, it's a little bit less than 4, a little bit less than 4 divided by 2. This is about 2. This is about 2, I'm going to say. And then therefore this number, what is this going to be? That's about 5. So negative 1 minus about 5 is negative 6. Negative 6 divided by 2 is about 3. This is about negative 3. I don't know if I'm allowed to use a calculator, but let's go ahead and assume that I don't. I'll show you how to do everything. So all of that work that I just did was justify the domain, which I still don't know exactly, but it's about that. Well, I guess I do know exactly, but I don't know what those are as a decimal. Now I have to solve the problem. I haven't even started on the problem yet. So on the problem, I'm going to say these things, let's set them equal to each other and see what happens, right? So I'm going to say, if I set them equal to each other, let's go ahead and come up over here. I'm going to say natural log of x squared plus x minus 5. Let's set that equal to, and find these boundaries, set that equal to natural log of x plus 4. All right, so now that these are set equal to each other, to see what happens, outsides, and this is technically base E, right? The outsides are the same, therefore the insides have to also be the same. And you can say this is going to mean that x squared plus x minus 5 is equal to x plus 4. And then solve. So solving this thing, I can just move the x over here, subtract x, they're gone and gone. If I subtract 4 and subtract 4, I get a negative 9 here. So I have really x squared minus 9 is equal to 0. And hopefully you recognize, hey, that's a square, and there's a difference here. This is a difference of squares, and you'll remember, yeah, difference of squares is a conjugate pair of x plus 3 and x minus 3. Is that equal to 0? And from here you can say, all right, that means that x plus 3 is equal to 0, or x minus 3 is equal to 0. Therefore, x is equal to negative 3, or x is equal to a positive 3. So those are the two answers. And then the question is, are they in the domain? All of that work that we did for the domain, we need to check. So, I guess, this is scary. It's about negative 3. And I mean, this one's about 2. Is x greater than 2? This number is definitely greater than 2. This number, is it more than negative 3 or less than negative 3? I think this is about negative 2.9-ish, if I had to guess, because this number is a little bit less than 5. Therefore, this number is a little bit less than 6. Therefore, this number is a little bit less than negative 3, or I guess greater than negative 3, because it's like negative 2.9-ish. I think this is okay. So we need to check all of these conditions and all of these conditions and make sure we get our boundary correct. This is super confusing even for me, so it's got to be like crazy confusing for you guys. Let's see. Number line. What are the zeros that we have? We have a 0 of negative 3. We have a 0 of 3. We also have some walls in place that says we have to be bigger than a certain amount. Let's see. What are these domains are kind of the hardcore walls. Let's see. I have a domain that have to be greater than negative 4. You know what's even bigger than negative 4? We have to be bigger than negative 3. So between this domain and this domain, this one is more restrictive. So, wait, but it's a, this is one of those things, like I put a less than there. Give me some time to think here. Okay, what I really want to do, I want to move this to make it a little bit scaled bigger, because I'm realizing I need the walls to go in between here. So we do need negative 3, and we do need positive 3. And then I need to write every single thing in the domain as well. So for the domain, I definitely need I guess negative 4. I don't really need the negative 4, do I? But I need to be greater than negative. Oh my God, I thought that this domain was superseded by that domain when I first said it, but it's a different direction. Okay, literally write everything in the domain and you'll never get it wrong. I'm just gonna write all 3 of these. The domains are like these walls, these boundary points that we're not allowed to go past. So where do we have this? It's about, I said this is about negative, I'm gonna call it negative 2.9 because I don't have a calculator. I'm gonna say negative 2.9 is this wall that's right here. I'm going to say right there is about negative 2.9-ish. And then right here, right about here, I have another wall that's going to be about, about 2-ish. So this number is a little bit less than 5. Therefore, this number is about less than 4. This number is less than 2. So yeah, a good number that's a little bit less than 2 is about 1.9-ish. And then these are going to be the hardcore walls that you are not allowed to pass. All right, I have room to draw my walls. So that's a wall, that's a wall. And then inside of these walls, they're like, this is no man's land. I'm not going to say that this is not in the domain. We can't have anything that happens in here. We can only exist out here. I also have another wall, right? This is the other domain. I have to be greater than negative 4, which occurs, again, there's negative 3. So negative 4 is right about here. So I'm going to say 4 is right about here. And that is, yet again, a wall. And I can't have anything over here. So over here, we can say not in the domain. Not in the domain. The only places I'm allowed to exist are here and then here to infinity. This goes on and on for infinity. All right, so, and what's happening at these spots? Do we have a sign change? Let's check the powers of those factors. Remember, those came from over here. These were both powers of 1. 1 is an odd number. Therefore, this can be a sign change. If this is allowed to be a sign change, I leave them as circles. If I had some sort of like 4 or 2, then they would not sign change. And I would put X's to remind myself they don't change signs. So what I need to do is I need to plug in a number here, and it will change signs. I have no idea what happens in here, so I need to plug in a second point and know that it changes signs when I jump over it. So what numbers do we want to test? A number that is, I'm scared of plugging in any number over there, actually. Let me slightly erase that. I'm scared of plugging in a number here because I don't know if that number is accurate. Maybe this is like 2.99. I don't know how big this number is. I don't have a calculator. Let's choose a number that's definitely in between. This is supposed to be -4, by the way. A number that's between, that's annoying, that's blue. Let's choose a number between -4 and -3, -3.5. I know that that number is definitely in here. So we have -3.5. Let's figure out if that number is positive or negative. So when I plug in -3.5, and all I have to do is I have to plug it in here. Everything else is fair game, right? If I plug in a -3.5, this number is a negative. This number is a negative. A negative times negative is a positive. This interval right here is a positive. And I know that it changes signs when I jump over this 0. So in this window right here, I am a negative. Okay, what happens over here? I have to do a new value. Again, I don't want to, I guess 1.9-ish. 2 should be in this interval. Let's go ahead and do a test point of 2. When I plug in 2, this number is going to be 5, and this number is going to be -1. A positive times a negative is a negative. I have a negative on this window, and therefore it's going to change signs over this 0, and it's going to become a positive. Whew. All right, we have done all of the math. It's now time to do the analysis, the final part of this problem. Under which of these 4 windows am I greater than, or sorry, it's saying where g of x is less than h of x, but we interpreted that as, I guess we want h of x to be bigger, so we want this number to be bigger. What side are we looking for? I guess what I did is I subtracted it over here. We want all of this stuff to be less than 0 because we move this over here. Where are we negative, I guess is the question. So what do we have here? We're negative there and there. Those are the answers. And that was kind of hard, so let me re-explain that again. Why am I looking for something that's negative and something as opposed to something that's positive? Because that will get your answer entirely wrong if you don't understand that critical link in our chain of logic. What I'm doing is I'm resetting up our problem, and the easiest thing for me to think about is to move this over here. That's how I found all this math. Remember when I did this and I subtracted the x plus 4 over in this direction? I'm doing the same move. I'm moving these over in the same direction, meaning that this function minus this function needs to be less than 0, which is the equivalent of saying, where do I have a negative bound? So when I come down here, my bounds are, this is going to be a sketch. This is not going to be my final answer. My sketch is going to say between -3 to -2.9-ish. That's supposed to be ish. And I also have the bound from 1.9-ish, all the way to 3. That's the final answer. The problem is, it's not, you can't just say -2.9-ish, you can't say 1.9-ish. These are exact values, which we did find way back in the problem. These things, all the way back here. So here we go. Oh, this is a crazy hard problem. -3 all the way to, okay, -2.9 came from this number right here, which is -1 minus root 21 all over 2. Those are in parentheses. And then this number is going to be, this is a union of these. And 1.9-ish came from this value right here. So it's -1 plus root 21. -1 plus root 21 all over 2, and that goes all the way to 3. And whew, oh my goodness, there is our final answer. I don't even want to really do this in inequality notation. Interval notation is good enough for me. And we have our final answer. Does it match the answer key though? Checking. Oh my God, we got it on the nose. That's exactly what they put in the answer key, although they did the inequality notation instead of the interval notation like I did. Pat on the back, Mr. Sindel knows what he's doing. I don't know if that means that you know what you're doing, but hopefully you're following me more or less. All right, example 6 is a much, much easier problem than example 5, and we're going to be done with this problem. All right, so we're just trying to find where is this function right here less than or equal to, and that might cause us to get the wrong answer. We haven't seen that yet in the notes. Less than or equal to negative 31. So I'm just going to rewrite this, but in the place of k of x, I'm going to write in the actual function. So I'm going to rewrite here. I'm going to say that 1 minus 4 times 2 to the power of x minus 3. This thing needs to be less than or equal to negative 31. Less than or equal to negative 31. Okay, so from here, we need to solve. I don't have any domain restrictions, which is a giant sigh of relief because that caused us to do the quadratic formula and the giant problem in the last one. No domain restrictions, just go ahead and solve. So I'm going to isolate this exponential, which means I need to get rid of this 1, I need to get rid of this 4, and don't make this mistake of doing, oh yeah, 1 minus 4 is negative 3. No, orders of operation dictate if you're just trying to simplify that the multiplication would happen first, you'd have to multiply by 4, and then you do 1 minus that answer, which means to do the reverse of that, I first need to get rid of 1 and then get rid of the negative 4 by subtracting the 1 and dividing by the negative 4. Let's do that. So to get rid of the 1, as I already said, we're going to subtract 1 on both sides. That will give us negative 4 times 2 to the power of x minus 3. That will be less than or equal to. Be careful here. When I subtract 1 over here, I'm subtracting 1 over here, meaning the right side is now a negative 32. I know some kids were probably thinking, negative 30. Okay, so from here, I need to get rid of the negative 4 by dividing both sides by negative 4, meaning what's left over is this 2 to the power of x minus 3 on the left side. On the right side of our inequality, we have a negative 32 divided by a negative 4. A negative divided by a negative is a positive. 32 divided by 4 is 8. This is 8. All right, and then from here, I need to solve. So what I'm going to do is I'm going to set this thing temporarily equal to figure out where these boundary points are, and then I'm going to figure out where those positive and negative intervals are. So I'm switching the problem up just a little bit. I'm going to say, okay, this is really the problem. 2 to the power of x minus 3 is equal to 8. How do I solve this one? Well, when we have exponential equations, what I typically try to do is have the same base and the same base and then just make their powers equal to each other. This base is 2, this base is not 2, but we can make this power, or this 8, a power of 2. Watch this. It's going to be 2 to the power of, you know your perfect cube, so it's 2 to the power of 3. Let me write that 3 clear. And then on the left side, I have 2 to the power of x minus 3. Now, because the bases are the same, the exponents must also be the same to preserve this equal to sign, which means I can create a new equation with their powers and say x minus 3 must be equal to 3. And then from here, add 3 to both sides, x is equal to 6. We're not done. This is a boundary point, and we need to come back and say, okay, on our number line, let's go ahead and draw our number line. On our number line, we have no domain restriction, no walls, but we do have this 6, and this 6 happened from an exponential equation, which means it's exponential equations will always be monotonically increasing or decreasing, which is a fancy way of saying they don't randomly turn around at that spot. They're going to go through it. These are always going to be odd. You'll never put an X saying, oh, they turn around at that spot. They always go through one way or the other. They can go down or they can go up. So all we need to do is figure out, are we positive there or are we negative there? We will know that the other one will always switch for an exponential equation. So just plug in a number, any number, because everything is in the domain. I personally really like 0. Let's do 0. So I'm going to plug in a test point of 0. When I plug in 0, and I have to plug in 0 into kind of anything that I want, I can plug in 0 there or there. I kind of like this one. It looks nicer to me. So what do I have? I'm going to have 0 minus 3. When I have 0 minus 3, it's going to be 2 to the power of negative 3. 2 to the power of negative 3 is going to be 2 to the power of... It's going to be 1 over 2 to the power of positive 3, which is equal to 1 over 8. Is 1/8 less than or equal to 8? And I think, yes, it's 1/8. It's very close to 0, in fact. So this is a true statement, I should say. So that is a true statement. 0 is less than or equal to 8. So we can say that is true for this area, and it's probably going to be false for this area. Here, let me show you something that's false. If I plug in something like 7, if I plug in 7, watch what happens. If I plug in 7, I'm going to have 7 minus 3, which is 4. 2 to the power of 4 is 16. Is 16 less than or equal to 8? No, 16 is bigger than 8. So this is a false statement. I can say this is false over here. Therefore, the answer is where we have truth, where we have something that is less than 6. And there's no wall making a weird domain restriction. It's just anything less than 6. You can say that either of these two ways. You can say anything from negative infinity all the way to 6 with our interval notation, or you can do inequality notation, say x has to be less than 6. Except I have purposely made a mistake. Finally, at the end of the video, if you can find my mistake, then you can get extra credit, pausing the video now, and you've unpaused the video. The the mistake is this sign right here. I knew it was going to come back and bite us. You have to have an equal to sign, which means if I come back here, this needs to be possibly equal to 6. The way that I need to change this to get the correct answer is I need to have a square bracket or an equal to for my final answer. Let's go ahead and check. Oh, answer key says I got it backwards. Let's go and find our mistake. Oh, and there it is. So when I divided by a negative, anytime that you multiply or divide by a negative, what happens to that sign? It needs to switch. This needed to be switched. So that is the mistake. If you caught that mistake, which was made on accident this time, you get the extra credit. And I would say you get 2 points of extra credit because that's a crazy mistake that I should not have made, which means these two are backwards. I can come back here and say this one should be false, and this one should be true. And I realized that there's actually an easier way to solve this problem, and it's to do this. If you leave the inequality instead of making a number line, watch another way that you can solve it. And I learned this from looking at the answer key. You can actually say, no, this is, leave the answer. Leave this as, watch this, leave this as greater than or equal to 8, which means this is still greater than or equal to. All I've changed is the 8 turned into 2 to the power 3. This is the key thing. If this side and this side have the same base and the powers are the same, this power must also be greater than or equal to this power. You can leave the sign here even though you're only talking about the powers. You can say this has to be greater than or equal to, greater than or equal to, and I could have gotten it right here. X is greater than or equal to 6 without having to do the number line. So I'm going to come back here and change my final answer here. So this is now going to say I go from 6 to positive infinity, 6 to positive infinity, where I'm equal to 6 and not equal to infinity, and x could also be greater than or equal to 6. So those are the two answers. You can either choose inequality notation or interval notation, and that does conclude the notes for topic 2.3, part 2 for AP Precalculus on exponential and logarithmic inverses and inequalities. There is the second page zoomed out, and there is the first page. Thanks for